Hi everyone, it is Sridevi, Professor Department of ECE. In this video lecture, we are going to learn about quantization and types of quantization, Nyquist criteria and logarithmic companding. So on completion of this module, the students will be able to understand what is quantization and they can also gain knowledge about mapping of continuous range of values to the finite set of values. That is what the main purpose of quantization. So initially, quantization, which means the digitization of analog signals, that involves rounding of the values, which is approximately equal to the analog values. So after quantization, what will happen is already the analog signals which is digitized or discretized in time, which is given as the input of the quantizer. Now the amplitude, which is already continuous, after quantization it will converted to discrete level amplitude values, which is called as quantization. The method of sampling chooses few points on the analog signal and these points are joined and round off some nearest values. Such a process is called as quantization. So let us have one analog signal like this. So this analog signal, both time and amplitude which will be considered as a discretized value, that is called as quantization, while rounding of amplitude of analog signal, some error because of rounding is called as quantization error. So quantization, that is our quantizing of the analog signal, is done by discretizing the signal, that is making the signal as discrete in amplitude in different quantization levels. So quantization is representing the sampled value of signal which is received as the input of quantizer. After quantization, the amplitude will also be considered as discrete values. So here this is a given input analog signal of the quantizer. So after quantization, it will be converted as discrete time amplitude levels. It can be done by different quantization levels. Both sampling and quantization results the loss of information. Because of sampling also the some error will be occurred, that is called a sampling error. So because of rounding or round off process in quantization, there will be some error occurred in quantization process also, that is called as quantization error. So this discrete amplitudes of quantized outputs are called as representation levels or reconstruction levels. So the spacing between two adjacent representation levels is called as step size or quantum. So this continuous time signal, we are quantizing this signal as 3 different bits, that is why it is represented as 0002 to 111, as 0 to 8 or 0 to 7, totally 8 input levels are there. This can be done with different types of quantizer, that is called as uniform quantizer and non-uniform quantizer. So uniform quantizer means the step size used for quantization is same throughout the level of quantization, and non-uniform quantization means the step size used for quantization is not same. The step size varies throughout the end of quantization, that is called as non-uniform quantization. In generally, it can be done by different two types of uniform quantization, that is mid-rise step size and mid-thread step size. So mid-rise means there is some rise in the origin, that is called as mid-rise. So it is called because the origin lies in the middle of the rising part of the staircase. So that is called as mid-rise. Mid-thread means the origin lies in the middle of the thread of the staircase like graph, that is called as mid-thread. Both these two types of quantizers are symmetric about origin. So here first one is called as mid-rise, there is in origin there is one rise. And mid-thread means in the origin there is one mid-thread, so that is called as mid-thread. So for any types of whatever it may be in this two different types, after quantization the amplitude will be discretized. So the continuous times amplitude of the analog signal will be discretized after quantization, so we can get both time and amplitude discretized signal after quantization. So because of quantization, that is the round of process happening inside the quantizer, some noise will be occurred, that is called as quantization noise. So this noise can be reduced by varying the step size. So original input signal, so throughout the signal levels the step size are same, means that is uniform. So here the step size should be selected in such a way that complete signal should be covered by the step size. So even though the complete signal is covered, there is some error, that is called as quantization error. So this error can be reduced by choosing the quantization as uniform or non-uniform quantizer, and the rounding of samples to the nearest quantization level, so that the error can also be minimized. So here in the continuous time analog signal, there is L equal to 2 power n representation levels are there. So delta is known as difference in step size, that is simply step size of the quantizer, that is called as delta. It is represented as x max minus x minimum divided by L. So n is number of bits used here, and after quantization we can find the round off value. So it is denoted by I is equal to x minus x minimum divided by delta. So here delta, the step size can be calculated with different levels. So here there is one example, the step size calculated. So different x max and x minimum levels are chosen for different L levels. L is calculated by 2 power n, and round off value is that is I is calculated as I is equal to the round off value between x minus x minimum divided by delta. And we can calculate the round of error also. So after quantization, the step size, because of the step size used uniform or non-uniform step size, we can get that different quantization errors. So after quantization, the amplitude of the signal is discretized. So we can have one quiz question based on quantization. That is, the question here is, the process of converting analog sample into discrete form is called, first option given as modulation, second option is multiplexing, third option is quantization, and fourth one is sampling. So here it is given as analog samples are converted to discrete form. So analog to discrete form, that is called as quantization. So option D, option C, quantization is the correct answer. So another one more question. In uniform quantization process, what is happening here is the step size remains same. Step size varies according to the values of input signal. The quantizer have linear characteristics, and both A and C are correct. A is given as step size remains same. So uniform quantization, we already know that step size remains the same, and step size varies, means that B is not a choice, and C, the quantizer has linear characteristics, that is also related with the uniform quantization also. So A and C are correct, so the correct answer here is D. So so here hope you can understood the concept of quantization. Thank you.